Hey guys, hi and welcome to your Unit 1 Lesson 3 notes on simplifying radical expressions. You'll recall that a radical is something that looks like this. Oh, radical, right? Okay. Also, you'll notice that this is Unit 1 Lesson 3a. I took Lesson 3 and divided it in half just because it got really long. So here we go. We're going to take it in pieces. By the end of the day, you will be able to simplify radical expressions. Now, a radical expression is any expression with a radical symbol in it. So what that looks like is you'll have the radical symbol, this guy right here, and nope, that was a struggle. The radical symbol, this guy, hold on, my Apple Pencil came undone. There you go, free plug. All right, this radical symbol right here we call the radical. So this guy is radical. And then there will always be something underneath the radical in this part right here. And we will call whatever is in there, like maybe it's just x, or maybe it's x squared, or maybe it's x squared minus 5. I don't know, something. It can be anything. Goes under there. We call that guy the radicand. Radicand. So it looks like radical, but instead of an L, you got the ND. And today, because you are capable, we are going to put the can do in radical. I can do that. Sometimes you'll see a radical expression which has an index. The index will be the number right here. Sometimes it'll be like 3, we call that a cube root. Sometimes it'll be a 2, we call it a square root. It can be any number. You can take the 10th root of an expression. But for the purposes of this class, it will always be 2. In fact, you don't even need a 2 there. If you have no number, like if it were to, disappear, why is it? If this were to, I'm trying to make it fade, but it's not. If it were to disappear altogether, then it's an implied 2. So there you go. Index is a 2. So our key of the day is simplifying a radical expression. And for a radical expression to be simplified, there are 3 things that need to happen, 3 conditions that need to be met. First, we'll say that no radicands have a perfect square factor. That is, what's here, what's under the radical symbol, doesn't have any perfect square factors. It's not divisible by any perfect squares. For your convenience, I have listed the first 20 perfect squares here for you. Were we in class, I would have you put this on an index card or write it on a sticky note or something and keep it for your records. Obviously, I can't make you do that, but I highly, highly recommend that you have an index card with these guys on it. So go ahead and pause this video and make this list on an index card. If you want to specify, oh, that's 1 squared, 2 squared, 3 squared, you can. You could even just label like the even number ones, like 16 is 4 squared, 36 is 6 squared, 64 is 8 squared, and 100 is 10 squared. And that way it's not as messy. You can still look at it and be like, oh, 81, that must be 9 squared. Okay. So no perfect square factors means you can't divide them by a perfect square. So we'll look at a couple examples later. Also, the radicand, remember that's the thing underneath the underneath the radical symbol, that can't have any fractions inside of it. Fraction is something like a over b or whatever. That cannot be under your radical. And finally, no radicals are in the denominator of a fraction. So we don't want any radical symbols in the denominator. In the denominator of a fraction. We're going to do something that's called rationalizing the denominator. I'll show you what that means. If we had to put this in pictures, because I like pictures, we can't have a perfect square under our radical. So we can't have anything squared under the radical. We also can't have any fractions in our radical. And we also can't have a fraction with a radical in the bottom part. So these three figures, that's the important thing to remember. I'm going to copy that and put that on our next page as a little shortcut. Hey, that's what we can't have. All right? So we're going to take each of these guys and put it into practice. Now you'll notice that the numbering got kind of weird here. So what we're going to do is I am going to do these, and then I'm going to have you pause the video after each one and try one for yourself. I'll tell you what the answer is, and then I'll make an extra video of just working through those problems in case you need the extra help. So again, we'll do these together, and then you'll try this on your own. Okay, first, the square root of 75. That breaks this rule because 75 is divisible by 25. We say that 75 is 25 times 3. Now, if you don't know that, if that didn't come easy to you, you can look at your list and you can take 75 and go, well, can 75 divide by 1? Yeah, but that's not helpful. 75 divided by 4 is not nice. 75 divided by 9, no. 75 divided by 16, no. But 75 divided by 25 is 5. And 25 is a perfect square. We can break this up into the square root of 25 times the square root of 3. And because 25 is a perfect square, we know that we can simplify that radical. The square root of 25 is 5. The square root of 3 is not rational. We're just going to leave it by itself. So the square root of 75 is 5 times the square root of 3. And that's it. That's our whole answer. So as you try to simplify 68, check to make sure that it's not divisible by any perfect squares. Now let's look at number 15. Number 15, we actually need to go backwards a step. We need to combine square root of 3 times the square root of 15 into 1. That's the square root of 3 times 15. I made that too long. I'm gonna run out of space. There we go. Right? Now that's equal to 45. 3 times 15 is 45. So we need to find the square root of 45. Now as I go through my perfect squares, 45 isn't divisible by 4, but it's divisible by 9. 45 is, 9 times 5. And 9 is a perfect square. So we're going to say this is equal to the square root of 9 times the square root of 5. The square root of 9 is 3. So we say that's equal to 3 times the square root of 5. So the square root of, what was the original problem? The square root of 3 times the square root of 15 is 3 times the square root of 5. And it just happens to be coincidence that we have 5 rad 3 and 3 rad 5. So that's funny. Now go ahead and try the second number 5. You'll want to combine these two first and then see if they have a perfect square in there. Okay, next we look at number 6, and we want to say, notice I'm going to do this in red because it's wrong. We want to say, oh, 32 divided by 4, that's 8. So this must be the square root of 8, right? Wrong. Instead, we are going to break this up as much as we can. Okay. Redo. That wasn't wrong, it was just the wrong way to do it. It's not the wrong answer, it's just the wrong way to do it. Okay. Here we go. Okay. So the square root of 32 is the same thing as 16 times 2. And square root of 4, well guys, guess what? The square root of 4 is 2. So we can just leave that just like that. Isn't that so nice? That's so nice. And we can break the top up into the square root of 16 times the square root of 2, all over 2. The square root of 16, well, that's a perfect square. Square root of 16 is 4. Then you have rad 2, all over 2. Now we're almost done. Here, our 4 reduces with our 2 to get 2 over 1. So we have 2 times the square root of 2, which is the square root of 8. That's how the square root of 8 is simplified. Fun fact for you. Okay, now go ahead and do that second number 6. You want to figure out, is there a perfect square in here? Break it up and then see how your fraction works out. We'll do a very similar process in number 7. So here in number 7, we have another fraction going on, but 5 and 10, they aren't divisible by any perfect squares. So we're going to do what's called rationalizing the denominator. To rationalize the denominator, I'm going to first spell rationalize. Why is that such a long word? Denominator, another long word. Denominator. Okay, whew. To rationalize the denominator is sneaky multiplying by 1. Man, I can't even spell correctly. Multiply by 1. Recall that whenever you multiply by 1, nothing changes. It's just 1. This doesn't change anything. This changes nothing. Now, when I say sneaky, I mean we're going to multiply by something divided by its same self, because that's 1. Anything divided by itself is 1. For example, I could multiply 2 over 2. It's still 1, but that's not going to be helpful. Instead, what I'm going to do is I'm going to multiply by the square root of 10 over the square root of, the square root of 10. Now up top, that gives me the square root of 5 times the square root of 10, which is the square root of 5 times 10. Now at the bottom, the square root of 10 times the square root of 10 is the square root of 10 times 10. Sweet! Let's keep going. 5 times 10 is 50. 10 times 10 is 100. Now, 50 is divisible by a perfect square. Whoa, I jumped all the way to the first page. Sorry, guys. 50 is 25 times 2. And the square root of 100 is just 10. So, leave that alone. So you have the square root of 25 times the square root of 2 all over 10. The square root of 25, because 25 is a perfect square, is 5. So that's equal to 5 times the square root of 2 all over, whoops, I got ahead of myself, I'm sorry, all over 10. And then 5 and 10 reduce to 1/2. So our final answer here is the square root of 2 all over 2. Ta-da! Let's go ahead and follow that same pattern with your second number 7. How fun. Okay, and now this is great, Miss Van Dyke, but when are we going to use this in real life? Well, I'm so glad you asked. Let's say that you're playing softball and you notice that the distance from second base to home plate is the square root of 800 meters. You would find this, if you want to know how we measured it to be the square root of 800, you talk to me after class. Now all we want to do is express the square root of 800 in simplest radical form. So So here we are. Watch this amazing drawing. Wow, that's great. Check out that amazing softball field. And you have like all the bases and stuff, right? From second base all the way to home plate. There, that's home plate for you. Is the square root of 800. So the square root of 800, we want to know what perfect square is 800 divisible by. And there are two routes you could take. You could say, oh, 800, I know that that's divisible by 100. That's 100 times 8. And that could totally work, except 8 is also divisible by a perfect square. So you'd be like, oh yeah, that's 100 times 4 times 2. Cool. But guys, guess what? There's an easier path. Ready? 800 is 400 times 2. And 400, you'll notice, is in our list of perfect squares because it is 20 squared. Ooh, right? Cool, huh? So 800 is 20 squared times 2. Isn't that radical? Okay, so we can break this up as the square root of 400 times the square root of 2. And as we just found out, the square root of 400 is 20. So it's 20 times the square root of 2. That's it. We're all set. Oh, except we forgot our units. Meters is the square root of 800 meters. So 20 read to meters. And now we're all set. Way to go, guys. Same thing, radius of a circle is the square root of 32 units. Express the radius in simplest radical form. So again, you've got this circle, and it's amazing. Look at that perfect circle I can draw. I'm just kidding. It's a shortcut. A radius is the square root of 32 units. So the square root of 32 is the same thing as the square root of 16 times the square root of 2, because 32 is 16 times 2. And what's nice about 16 is it's a perfect square. 16, I hope you can't hear that leaf blower outside my window. 16 is 4 squared. So that's the same thing as, whoops, 4 rad 2. And 4 rad 2 units. Here we go. Perfect. I hope you enjoy the rest of your lesson. Remember, if you need help on these guys, oh, I didn't tell you what the answers were. I'm so sorry. I totally forgot. This number 4, if you haven't done these yet, look at these as examples and do them. And now we'll check our answers. This should come out to 2 times the square root of 17. This one is 5 times the square root of 7. This one is 2 times the square root of 3. And finally, this is the square root of 3 divided by 2. If you need more help with those, go ahead and check out the extra explanation video that I will post on Schoology, and it will take you step by step through each of those guys. Right? And that is simplifying radical expressions. Make sure you always check you don't have a perfect square underneath your radical, you don't have any fractions underneath your radical, and you also don't have any radicals within your fraction. Have a fantastic day, guys.